Welcome, everyone. We're going to be starting right at 1 o'clock, which is in about 4 minutes, but always appreciate people joining early just to make sure that any tech issues are sorted out. And while you wait, we do have a opener question for you up on the screen. So if you could think about and then answer in the chat, why are you interested in compressed air audits, which is our focus for today? Right, we heard from Wolfat. I've just finished the CIP course and would like to know more about the topic. Great. This will be a good opportunity to dive more into specifically the audit side. And for those that have just joined and have joined early, we will be getting started promptly at the start time in just a couple of minutes. In the meantime, we do have the question on the slide. Why are you interested in learning more about compressed air audits? So if you could answer that in the chat just while we're waiting to get started, it would be appreciated. Also, reduction of energy used for compressed air production, reducing leaks. Excellent. All right, already doing your own audits. That's great to hear, Matthew. Just looking for any tricks to pick up along the way. Great. All right. So more people will be starting to trickle in now that we're at 1 o'clock. We're going to dive into it. This is going to be, you are going to have opportunities to interact, participate. So we do encourage people to turn on their cameras, unmute, say hi. Please stay muted if you're not talking, but please feel free to raise your hand and come off mute if you do have any questions throughout, or you can continue to put questions in the chat and we'll see those as we go. So for those that did join on time for this webinar, as we are about to jump into it, I would like to hear in the chat, why are you interested in compressed air audits? We've had some really great answers from the participants that joined early already, but as we go through the intro, please think about that and let us know why you're interested in this particular topic. Because today we are talking about conducting compressed air audits. I'm Jay Mullen, an energy coach with Save on Energy, and I'm really excited to have Ron Marshall joining us today from Marshall Compressed Air Consulting, who brings a plethora of experience in the world of compressed air that you get access to. So please take advantage of this opportunity and ask questions as we go. But thank you for joining us, Ron.
Glad to be here.
I also have my colleague Evan as producer for this podcast to help make sure everything goes smoothly. So if you have any questions or technical issues, please let them know in the chat and we'll address that. We do have a participant workbook as part of this. Evan, did you see that message there of someone having trouble joining the meeting? Or they're coming in now. Okay. We do have a participant workbook. Evan's going to drop a link to this in the chat. So you can follow that link to a read-only copy. I encourage you to click the download button, save your own copy. You can have it open as we go along. It does summarize a lot of what we're talking about in this workshop, as well as some areas to fill out, to think about, how does it apply to your organization, and fill that out in notes as we go. And there's some worksheets and additional resources listed in that. So please do download that and follow along. So today's workshop is about compressed air audits, and we're going to start off by, understanding the purpose and drivers behind conducting an audit. Like, why do organizations typically do these? What do they try to get out of them? What are some of those benefits? Then we're going to talk about when an audit is needed, what you'll want to include in the scope. And then lastly, we're going to start looking at how to plan the audit that's right for your facility. So as we go through these sections, please think about how it relates to your organization, to your facility, and we're hoping that you will get lots of practical tips, takeaways. If you do have any questions, please raise your hand and we'll get to those, or type it into the chat and we'll pick them up as we go along. So to start off, let's think about why facilities conduct compressed air audits. Compressed air is essential in many facilities. It's often called the fourth utility, along with electricity, water, and gas, and it's probably your most expensive utility on a unit of work basis. And compressed air can represent a pretty significant cost to your facility, and yet most facilities don't meter energy consumption of their compressed air system, and many don't even have flow meters, so they don't even know how much compressed air they're actually using. So because of that, it might not be surprising. It's not uncommon for a facility to be able to reduce compressed air energy consumption by 20 to 50% without much effort, with some like low cost, low effort opportunities. So to illustrate the level of impact that this can have, Ron, I think you have a couple of examples that can you walk through and kind of show us?
Sure. Yeah. And this ratio that I'm going to be talking about is what got me in the business 30 years ago when I was a raw recruit to this energy management thing. And I attended a course. The course was intended to raise people's awareness about the cost of compressed air, the high cost of compressed air. So if you advance a little bit, there should be a graphic that pops up too. Very good. Thank you. Yeah, so the course basically said, and this is a course from the Compressed Air Challenge, Fundamentals it's called, uh, tells us that to produce a 1 horsepower output at the shaft of an air motor like this, that's showing us a vane motor, right? It needs about 30 standard cubic feet at 90 pounds, right? At the compressor element inside the compressor, the shaft, six or 7 horsepower is required to turn that shaft. And then there's an electric motor, of course, between the input electricity and the shaft. 7 to 8 horsepower of power is required at the compressor to produce 1 horsepower at this device. Now we're using an air motor as an example, but there's other things like cylinders and all kinds of tools and equipment that have similar or worse energy conversion ratios. Now this slide indicates that 10 to 15%, you can go on to the next slide, sure. 10 the overall efficiency of a typical compressed air system can be 10 to 15%, right? But that the numbers that we were talking about are kind of laboratory conditions, right? It's almost like when you look at the sticker of the gas mileage on a car, right, in the showroom. Do you really get that gas mileage in real life conditions? Probably not. laboratory system, the compressor could be operating inefficiently depending on its mode. So some really inefficient modes of operation can consume more than double uh, the energy in that laboratory conditions. Also, there's pressure loss in a system that's not occurring in this real life that's laboratory condition, and also typical system has 30% leaks. So 30% of the air is leaking out of the system before it gets to that device. So that may cause the efficiency of the system to go down maybe to 3 to 5%, right? So it's kind of indicating that compressed air is a really inefficient way to transfer power. And we should be aware of it. And if we are aware of it, then we can perhaps do something about it, right? And if we advance a little bit further into the slide, we can see a comparison. And this is the air motor example again. Compressed air motor, and this is only 4,100 hours per year. 1 horsepower air motor would cost $2,330 to operate, and electricity, if we advance, would be 390, right? A direct drive electrical power to that device. So pretty significant. It's only 4160. Very often end uses can operate 24/7, and the ticket, the cost of that would be much higher than this, right? So it's an example of the savings. This is what blew me away when I started in this industry.
Right. So that's one of the big reasons why an audit is such an important tool to provide visibility around that system performance, identify, quantify that waste that Ron was talking about, like 30% leaks. Are you operating that system inefficiently, and support those decisions either to improve the performance of the system, or if you are looking to upgrade or expand. Um, so, Ron, give that's huge savings potential. But what do you see as the biggest drivers for companies that when they do get around to conducting a compressed air audit of their system? Like, what are the reasons why they're doing that?
Yeah, I think we have a slide about that, but typically some company will be having problems with their air system, problems with the air system. There could be issues like low pressure, water in the oil, water and air, uh, and oil in the air, excess amounts, right? Maybe their compressors are failing or needing replacing. They might be wanting to expand their system, right? So that they want to know where they are in terms of flow. If they're not measuring their compressed air, they have no idea whether they've got lots of capacity or very little. And sometimes there's a corporate mandate. There'll be a mandate saying that we need to be sustainable, we need to reduce energy, and people are aware from things that they see on the internet that compressed air is a really good uh, utility to look at to solve energy problems, right? Energy efficiency problems. Now, these first bullet points are problems in the system. Those problems can be solved by doing an audit, uh, applying some measures, right? And with that comes energy efficiencies, sometimes on the coattails of greater, more valuable savings. This is an example, a case study, an automotive plant that I did an audit for. Their compressors are failing, right? They occasionally had low pressure problems, right? They called me in as a compressed air auditor just to take a look at their system. Um, we put measurement devices on, measured pressure, flow, power, and we could see by the data that was collected, there's a failed valve in a desiccant dryer feeding a breathing air purifier, and that was causing the problems, right? They had no idea about that problem. It was considerably costly, costing them a lot of money. And in the meantime, we could see the flow measurements. If they fix that failed dryer, they could replace this failing compressor with a smaller compressor, saving future costs, right? And we also found a 20% leakage level. We could tell that from the flow meters. And if they fix this, they could have further reduction in cost. And if they did their compressor control well, they could gain a lot of savings from their efforts. If the compressors were controlled poorly, then the savings are not as much. Here's another one, a fiberglass plant. This is in my neck of the woods too. They they had they had a single 60 horsepower variable speed drive and a 50 horsepower fixed speed compressor. They called me in. They were having problems with a key die cutter. So they're trying to cut these fiberglass pieces out of the molds. This die cutter was really sluggish and not performing well, and they were just wondering what to do about it, right? So we went in, did an audit, and we can see the pressure profile of what we found. You know, the compressors were actually supplying good pressure to the plant, yet pressure losses across the system, in particular the last 30 feet, we call it the dirty 30, the last 30 feet of hose feeding that die cutter were causing problems, right? So that was discovered by measuring, right? They also had pressure related problems with other pieces of machinery too in their plant. They weren't measuring anything, and things were unknown, right? So doing an audit allowed them to know what the operating costs were, establish a baseline, right? And then we could see what components of the system were costing what amounts, right? We found, we can see in that spreadsheet to the right, something to do with a heater, right? Its fiberglass plant is very dusty. So their compressor room was fed with 100% outside air. And of course, around Winnipeg here, the air is getting pretty cold in the wintertime. They were using an electric heater to heat the air going into the compressor room, right? But they didn't realize that a compressor, you know, 80% of the energy going into a compressor comes out as heat. They could use the heat of compression to temper that heat going into the compressor room rather than using an electric heater. So that 6450 cost was something that something could be done about, right? And then we looked at other costs, high maintenance costs because the compressor was failing, lost production due to low pressure, all added up to a significant amount of money.
Ron, we have a question from Olpat about what got them to think about looking at the compressor line rather than just focusing on like the press or the big machine as a source of the issue.
Measurements. So why did they look at the compressor line? Well, because the auditor told them, right? I told them to look at the compressors, right? And we looked at everything, right? You have to kind of look at the system as a whole, go from the most critical pressure end use and work your way backwards through the piping to the discharge of the compressor and find out where the problems are, right? And to do that, you have to do pressure measurements, typically time-based analysis with portable data loggers, and that's what was happening in this case.
Okay.
One thing that I did do there was I hooked up a little T connection on the input to that die cutter. It's just a hand tool, right? A T connection, male and female quick connect coupler with a gauge. I looked at the gauge before we pulled the trigger of the tool. Looked to be about 110 psi normally. We pulled the trigger and the pressure went down to 40 pounds. So that was an indication of the pressure drop right at that local location. Very poor feed piping and connectors, right? Too long and too small. So very quickly could determine what the problem there was.
Right. So normally, if it had time to build up that pressure, it was getting enough pressure. But as soon as there was that big demand, having that gauge right there showed that it couldn't supply the air to sort of maintain that through the hose.
Yeah, there's 70 psi drop across this undersized hose. Yeah.
All right. And I think we have some more info just from that case study.
Yeah, so in doing the case study and establishing a baseline, we broke down all the different components that could result in some savings, right? So if they purchased a new compressor, a more efficient compressor, and dropped the discharge pressure, the 31% savings could be gained. If they fixed their leaks, 12%, got rid of some inefficient end uses, 4%, better filters, a small amount, go with a cycling dryer rather than non-cycling refrigerated dryer. They were replacing the dryer anyway, 5%, so that was extra icing on top of the project, right? They could turn that heater off and use compressor heat to heat the room, 16%. And they could actually turn the whole system off at night and on weekend and save some 5%. So this is a pretty significant savings, 74% could be saved by implementing all those measures. And on top of that, newer compressor, less maintenance, right? And better pressure, less loss of production. So many operators want their system to run in a trouble-free manner. Energy efficiency is important, but in most cases, the value, the most attractive value to people that have their system studied is the reliability gains, systems running without interruption, better stability of pressure, and better air quality, right? Those things can be solved by study as well, right? That's part of doing an audit, is looking at all of those things as well.
So, so yeah, there's a lot of those benefits to be had on the operation side. Um, I think before we get into the details of what's involved in the audit, just making sure that we're all on the same page of what it is. So when we talk about a compressed air audit, we're talking about a systemic evaluation of your compressed air system performance that includes looking at supply, distribution, and demand. And as Ron mentioned, there's lots of benefits beyond those reduced operating costs that come from it. Um, so when we say that audit includes an assessment of supply, distribution, and demand, this is what we're talking about. The equipment that supplies the compressed air, including compressors, dryers, storage tanks, all of that sort of stuff. That's your supply side. Then everything on the demand side, including the distribution pipes, end uses, like Ron mentioned, like those distribution hoses, the presses that use the air, um, even the types of thing, even like what compressed air is used for, is compressed air the right use for that application? All of that's part of the demand side. So if you only look at part of the system, you're only going to get part of the picture. And we mentioned earlier that an audit is evaluation of performance. So Ron, what are some of those key performance measures that are typically included or that you want to include or look for in an audit?
Yeah, sure. So these are some of them, and it's not an exhaustive list, right? Key performance indicators that can be calculated or observed from the baseline measurements, right? So kilowatt hours, of course, that helps track the costs, right? But you want to know how efficiently that compressed air is being made, right? And specific power, if you measure the kilowatts consumed by the compressed air equipment and divide it by 100 CFM, that gives us a number that's very commonly used in the industry. I jokingly call it a gas mileage, right? Because I can look on my truck, I can push a button, and I can see the liters per 100 kilometers. So my feverish little mind tells me that that equates to efficiency. So you have to make compressed air more efficiently and use less compressed air, right? So when you're making compressed air more efficiently, that relates to the kilowatts per 100 CFM. And when you use less compressed air, that relates to the kilowatt hours, right? And then from the time-based data, we can also observe during plant shutdowns, things like that, or special testing, what the leakage level is, and that also feeds into the kilowatt hours, right, that are consumed by the compressors, right? And then if a study is done or observations made, even internally, you can make a list of potentially inappropriate uses like blowing for cleaning, like using air motors instead of electric, things like that, that could be either eliminated, optimized, or maybe looked at in a different manner, do some engineering on it, and pick away at those to get rid of the compressed air load as well. So the key principles, I already talked about this. Secrets that compressed air auditors don't want normal people to know, right? But we can say it to you because there's thousands of different ways to do it, right? So basic ways to improve compressed air system efficiently: compress the air more efficiently, right? Use less compressed air. Reduce the compressed air pressure, and that feeds into both number one and number two, right? Because compressing at higher pressures consumes more energy, and compressing at higher pressures and then feeding it into the plant causes more air to flow into the plant. And then number four, use the heat of compression. We saw an example of that already, right? Use that heat for something, right? It could be space heat, it could be making hot water, it could be feeding into a process, um, boiler makeup, all kinds of things that could use that. It's kind of low grade heat, but it's still heat that could be used for good instead of evil. So lots of sources of waste. Definitely the most common talked about is leakage, right? Some 20 to 30%, sometimes as high as 80%. And I have an example coming up about the 80%, right? That's my personal record that I found during my auditing career. There's artificial demand. Artificial demand is kind of strange. Remember, I just said that feeding the plant at a higher pressure causes more air to flow, right? The load in a plant just looks like an orifice if it's unregulated, right? And the higher pressure you feed an orifice, the more air flows. The relationship is about 1% more flow for every 1 psi, right? So that we call artificial demand. So if you're feeding the plant higher pressure than desired, 10 to 15 on average, extra flow is feeding into the plant. And then inappropriate uses, usually you can find 10 to 15% of inappropriate uses that could possibly be optimized or eliminated, right, to save the flow. Poor compressor controls also cause problems, right? So for example, if you fix 50% of your leaks, but your air compressors are not controlled properly, you may get only a fraction of the savings gained because the compressors, very often compressors do not turn their power down in direct proportion to the reduction in flow, right? So that's something that's always checked when you're doing a compressed air audit. And you could have inefficient equipment like old style compressors running in poor operating modes, very inefficient air dryers, clogged filters or filters that are not sized properly, and drains that are draining away that expensive compressed air. And we can see on the right examples of wasteful uses or abuses of compressed air.
We have a question about whether the specific power of compressors, the kilowatt per 100 CFM, does that change depending on the manufacturer, type of machine, or what influences that?
Yeah, it changes. Um, Now there's an organization called Compressed Air and Gas Institute. I'll call it KGI or CAGI. Now they have ratings, data sheets that manufacturers use. They're required if they're part of KGI to publish these sheets for their compressors. And you can see every manufacturer is required to have a library of these sheets, and you can browse through these sheets and see, some of the older design compressors are not as efficient as the newer design. And that can tell you, or that can point you to, when you're buying compressors, to which ones you should be going with, right? To make your system as efficient as possible. So air compressors, yes, kilowatts per 100 CFM matter and change with various manufacturers, makes and models, right? And as well, air dryers. Refrigerated air dryers have KGI sheets as well that can help you choose the correct and most efficient air dryer for your needs. Hope that answers the question.
Yeah, I think so. And also, like whether you're operating at full load or part load, that can influence that specific power as well, depending on how the system's controlled, right? Because like in some compressors, they don't turn down very well, so you might have a higher specific power if you're at like 60% capacity than if you're at full capacity. Is that accurate?
Yeah, that's accurate. It depends on the control mode. There's various control modes. If you went to the compressed air challenge fundamentals training, you would get a tutorial on the various control modes. So some control modes, for every 10% reduction in flow output of the compressor, there's only about a 3% reduction in power. But say for a variable speed drive compressor, it's pretty close to a 1-to-1 relationship. So for every 10% reduction in flow, you get a 10% reduction in power. So that's, two extremes on either side of the efficiency curves of compressors, right? And there's various control modes in between, right? Like load unload,
Hmm.
uh, variable displacement, things like that. Now, the tough part about part load efficiency is it's very difficult to assess what the characteristics of the compressor, because there's no published curves for fixed speed compressors, right? All we see is fully loaded kilowatts and unloaded kilowatts on those KGI sheets. There's no curves. So if you signed up for the fundamentals training, you would see some banana curves that we use to show you, based on the storage size, how efficient a compressor, fixed speed compressor, would be if it was operating in load unload mode, or in modulation mode, or variable displacement mode.
Okay. Um, Now, I know one of the common questions we get from people looking to audit is, can we do it ourselves? So there's different approaches depending on what you're looking for. Sometimes you can have your own staff conduct the audit. People are often excited when vendors offer to conduct a free audit for them. And then, of course, there's independent auditors that, this is their job. Do you have any insights in terms of the pros and cons of those three different approaches of who should be conducting the audit?
Yeah, um, there are pros and cons. I'm assuming you're asking me. Sorry.
Yeah, yeah.
Yeah. So the staff, if you're doing it yourself, and I would really recommend somebody in a large organization, especially if you have multiple plants, right? Become an expert in compressed air systems. Take the training, right? And get up to snuff on doing baselines of compressed air systems, right? So very rarely are there staff at adequate level and knowledge levels to do an audit. Sometimes there are, so that makes doing it yourself more difficult. The equipment suppliers, right? They really focus, because they're in the business of selling compressors and dryers, right? And not really in the business of looking after end uses. So it's very rare to see an equipment supplier that's supplying with a free audit do anything on the demand side, right? So that's the tough part. Independent auditors, yes, they can do everything, um, but there's not very many of them, right? Um, and sometimes in certain jurisdictions there might be some incentives available or money available from energy organizations to conduct these audits, but it'd be nice to have something like that in Ontario. Hopefully that's being developed right now.
And in terms of after who conducts the audit, the biggest question we hear is like, okay, what do we need to measure? And we did have a question from Olfat earlier about like what are the best spots in the system to measure pressure, flow, things like that. Um, so we're going to get to that, but like, what are some of the key pieces of data that are important to assess that performance?
Sure, yeah. So, when you go to the doctor, they put these probes on your chest, right? They can see how your heart is working and in internal organs sometimes using other test methods without cutting open your body, right? They can see how things are working and measure applying measurement instruments to a system does that kind of thing, right? If we use our imagination, we might think that a compressed air system would be like a circulatory system in a human body. Go ahead and advance to the other bullet points. Yeah. So it's important to establish a baseline, right? So you can find out where you are now, right, and all the different conditions of the system. You can use that baseline to track how the system is going over time. If things are improving, right, you might implement a project or even uh, get your compressors running a little bit better, right? You can see if you're tracking baseline or having your system measured, if it's getting better or getting worse. And then you can use the money to convert the savings or additional costs into dollars and communicate to management, right? You perhaps you do something simple like fixing leaks and optimizing the compressor control by adjusting the set points. If that saves quite a few thousands of dollars, you can report that to management and perhaps they'll trust you to do maybe something a little bit more expensive, right? And get further savings. So, yeah, things that are measured flow out of the compressor room. It's quite important. It can be calculated, but it's tricky, right? Tricky. Pressure at the compressor discharge, well, that's a primary important parameter of a compressed air system. The whole reason the compressed air system exists in the first place is to create pressure, and you need to know, the pressure at the discharge of the compressor and what the pressure is in various points, critical points of the system. Measuring the power of compressors and dryers is important. Sometimes amps are used and power is calculated, right, using various assumptions. And leakage, it's important to do some sort of leakage measurement. It could be done observing the main flow meter if you have a flow meter there, or doing point by point leakage, ultrasonic leakage detection uh, effort, right? That could be done. And then temperature of the compressors, dryers, and various points. Temperature is so very important, and high temperature causes a lot of issues in terms of reliability of the compressor and the air quality, right? If the air going into the dryer is too hot, the dryer can't handle it and water goes into the system. And then water and oil start to cause contamination problems in the system. Enhanced measurements could be done, leakage, special leakage work, a survey of inappropriate uses and measuring the inappropriate uses, pressure drop at various points, dew point of the air coming out of a air dryer, right? The oil content, there's measurement instruments that can measure that. If you're in a food grade food plant, it's very important to have clean compressed air, especially if it's getting close or contacting your product. Um, there's even specialized instrumentation that can do laser measurement of particle size. Very often that's important in, say, pharmaceutical or clean room applications, right? Food grade plants also need to reduce the microbial contamination. So you can measure that as well. And system reliability, right? Enhanced measures that could be done in addition to the basic measurements.
Right. And we had a question from Olfat about how long does an audit take? Oh, wait, before we get to that, there's a question about what do you use for microbial contamination?
Yeah, there's a special test method using Petri dishes, right?
Okay. So yeah, another question that we had is how long does the audit take?
Right, and we have slides for that. So, you know, some utilities, especially if they're feeding money into a project, would love to have full year worth of measurement, but that's impractical, right? You got to buy these fairly expensive instruments and have them tied up for a year. So that's not going to be uh, we're not going to be doing that. So what typically is done is a few weeks worth of data logging is done, and then we assume that the system will be running that same way for all year, right? And we project forward, right? When we measure, we'd like to do repeating periods. So very often it's a 1 week period, right? Monday, Tuesday, Wednesday, all the way to Sunday again, right? There'll be repeating periods, and we might do, you know, more than just 1 week, could be a month's worth of repeating periods. And we would determine, you know, the KPIs within those repeating periods, and then multiply by the number of hours that system might be operating, right? We need to take into account some food plants are seasonal, right? So if we take a reading during the high season, it may not equate to a full annualized cost if there's quite significant time in a light loading condition, right? So we have to make sure that that's accounted for. Um, but the typical minimum measurement in a regular shift oriented plant is about 7 days, and or if it's longer than that, we would slice the data up into 7 day multiples. And uh, sometimes you have to break the data into day types, right? If there's different processes running on Monday, Tuesday, Wednesday, and then Thursday, Friday are different, right? We have to segregate those days, add up the number of days of each day type to come out with a really good annualized baseline.
And we talked about, some of the things that should be metered, but I'm curious, as we mentioned earlier, a lot of the facilities aren't collecting data on the compressed air systems. Are there particular measurements that, like, if you don't have permanent meters installed, that you really should consider getting those to start collecting that data outside of like that 2 week period of an audit?
Yeah, so we can see here some of the basic measurements on this slide. Now, there's usually no shortage of pressure measurement devices on a compressed air system, but very often they're just analog and nobody's reading them unless there's a problem, right? There could be maybe an analog gauge outside the supervisor's office that he can look up and see the pressure, right? And if he's getting phone call complaints and the pressure is low, he can perhaps go and turn on another compressor. But having permanent metering that's electronic, that's feeding into a database is quite important for, say, troubleshooting, right? If you want to know the cause of that low pressure, you have to measure. So definitely pressure, before and after the dryers and filters is important. The power consumption or amp consumption of the compressors. Amps you can convert into kilowatts using some assumptions. Flow is quite important in my mind. You can calculate flow from compressor characteristics, but it's better to have an actual flow meter showing what's going into the plant, and that tells you all kinds of stuff. And then if air quality issue is important to you, measuring the dew point coming out of the system and or the temperature of the air going into the air dryer is quite important too if you want to maintain the high quality of air so that you don't have contamination. So
Hmm.
I would suggest that any system, of anything over 100 horsepower should have permanent meters running into some sort of data collecting device. There's various manufacturers that can offer that, for you, to you, so that you can have a system like that.
Okay. We had a question before of like in the audit, you mentioned measuring pressure or flow or at different points. Are there key points through like the distribution system that you might want to be measuring flow or pressure at?
Yeah, definitely at the discharge of the compressor, at the discharge of the compressor room. And then it just depends on the system, right? There'll be various different critical pressure applications in a plant. So say the far end of the plant, this is a application they always complain about low pressure, right? And that's causing the pressure discharge of the compressor to be adjusted up. When you adjust up, everything else sees the high pressure as well. So measuring at those critical points, right, that are always complaining,
Hmm.
that's important. And then at various points in between, so that you can analyze where that pressure loss is, right?
Okay.
So here's an example here of a pressure chart only. There's pressure charts, various points, so we can see discharge of the compressor after the dryer, right? This is a system, and it's a wet and dry system, so it's a paper mill. So they actually use undried compressed air for some crude operations like blowing and threading the paper through the machines and stuff like that. So we can see the pressure at various points, and we can see, curiously, the pink and the green points are very much lower than everything else, right? And that was an unexpected discovery. And we found that the cause of that was an old abandoned orifice flow meter that was put in the plant 30 years ago, and it had been clogged up with debris and rust and stuff like that. So in only 6 inches, there was that massive pressure drop, right? And the way we discovered is we kept moving the pressure monitoring devices closer and closer to the compressor room and found that location, right,
Hmm.
with the orifice plate. You can take the readings off that chart, and you can perhaps do a chart like this. And this is from the Compressed Air Challenge Fundamentals, right? So you can see where the pressure loss is. So we can see operating range of the compressors. That's control of the compressors. They might be loading and unloading between 100 and 110. There's pressure loss across dryer and filter, right? Pretty significant in this case, 10 psi. That curve, that blue curve, is the pressure loss across the distribution pipework. And it's a curve because it's as the air gets farther and farther away, it expands, right, due to the pressure loss. And there becomes more friction because of the expanded air, right? So there's an exponential curve there. So in this case, it's 5 psi, not that bad.
Hmm.
And then the pressure at the end use, the down drop to the device that's using air, this might be a pressure critical device. We can see the pressure loss. FRL is filter regulator lubricator, valves, hoses, quick connect, disconnects. In this case, it's 15 psi. So we're producing air at 105, and we're only getting 70 psi at that critical pressure end use, right? So it shows us where we should focus our attention, right?
Hmm.
So for a few $100s, we can fix that problem at the end use, right, and get better pressure. a few $1,000s, we might be able to loop the piping and get rid of some of that distribution pressure drop or increase the size. And multi-thousands might have to be spent to upsize the dryer, do better filtering, right? To
Mm.
address the problem in the compressor room. And all those three things would allow you perhaps to reduce the discharge pressure of the compressor, get better, more stable pressure at the critical end use, right? If you address that. Now, if we reduce the pressure at the discharge of the compressors, so the relationship is for every 2 psi we reduce that pressure, the compressor consumes about 1% less power. Here's an example of we've now added to that same chart. We've got pressure. I think that pressure is at the discharge and then at the output of the dryer. But we also have kilowatts, right? So we can see, curiously, there's a couple of really bad dips in pressure, and it's pulling down the power of that compressor. So that's kind of proof that what I just said is a reality, right? As the discharge pressure goes down, the power consumption of the compressor goes down. So that's an indication for seasoned chart readers like me that system is in drawdown. There's not enough capacity to feed the high flows. And then we can see over to the right more, we can see some sawtooth waveforms, right? That's an indication the compressor's loading and unloading. We can see one compressor, that big red fuzzy one, unloaded, right, to a lower level, and it starts at the far right end of the chart. It's loading and unloading, so we can see from the power and from the pressure reading what's happening there, and we can understand what's happening. Next chart is we add flow to it. I've moved the kilowatts down lower so we can understand what the flow is. And this flow chart confirms what I was suspecting, right? We can see with those low pressure dips, right? There's a high flow increase, right? So that shows that those dips are caused by flow, right? And we can also see as the compressors unload, right, the flow is going down, and we can see the sawtooth waveform where the compressor is loading and unloading. So three things on the chart that help us understand what's happening on the system, and we can troubleshoot problems. We're seeing that there's a lack of capacity in here. It's a short duration capacity increase, so that is something that can be addressed with large storage tanks, actually, instead of having to install a bigger compressor. Here's an example leak survey, right? It's good to do leak surveys. I would suggest quarterly in a plant. I know somebody mentioned that they were doing an audit with their fluke device, right? So that would be acoustical leak detector, acoustical imager with a fluke device. So typically 20 to 30% of a plant on average is lost due to leaks. So if you have an ultrasonic gun or acoustical imaging device, you can very quickly find where the leakage is, even in a noisy plant, right? Those detectors block out the ambient noise, and you can just hear leaks. Not only compressed air, but steam leaks, vacuum leaks, gas leaks. Maybe you're using argon or oxygen or other gases, nitrogen. They're much more costly, the compressed air, so it's a side benefit in doing a compressed air leakage study. You can find those gases as well. So typically, if your compressors are controlled well, you get a fast return on detecting leaks. If you don't have good control, limited savings, right? And then you could use your main flow meter, say on a shutdown or weekend, right? Have somebody look at the flow meter, the reading on the flow meter, and see how much air is going into the plant, and that's an indication of leakage as well. Over to the right, we can see a spot on that crane where the leakage is happening on this. So that's an example of a acoustical imager, cutting edge technology just recently developed, and something that a large plant should have.
We have a question from Arda about how we got to the conclusion that there was a lack of capacity. And I think the main thing there was you could see as the flow spiked up, the pressure dropped. And if you had greater storage capacity in the system, it would kind of smooth that out. Is that correct?
That's right, yeah.
Okay.
Yeah, I kind of equate systems like a bank account, right? So if you put less money in than you take out, the bank account balance must drop, right? If you have $1 million in that bank account and you take only a few thousand, right, the balance doesn't change very much. Same thing with air systems. If you've got large storage and you take a little bit of excess air out, right, then the pressure doesn't change very much, right? So if you have little storage, the pressure fluctuations are a lot.
Mm-hmm. And then, not all problems need to be an audit. Sometimes there's mechanical, electrical problems. One thing, sorry, we had a question about like when should an audit be conducted? Are there typical triggers, or is there a certain frequency that it should go on?
Yeah, there usually is triggers, and I think we have an upcoming slide. Well, this slide actually. Very often, they're planning an expansion, so they need to confirm their sizing, right? That would be a trigger. If they're having low pressure events, they have no idea what's causing them. That could be a trigger. If water's pouring out of their compressed air system, they can't figure it out. That'll be a trigger. And very often there'll be some corporate strategy or a mandate handed down from management. They need to know the cost of that very expensive utility, and they have a mandate to become more efficient, right? Those are triggers.
Okay. Yeah, and I think we have a summary on there. Is there anything to add, or I think this kind of summarizes those key points?
Exactly.
Okay. What about in terms of like size of the plant? How might that influence what people do?
Yeah, for smaller size systems, well, it does, doesn't pay, right, to to bring in high price help, right? If you're only spending a few $1,000s in compressed air costs, right? You can't support a significant audit of a week or so, right? So with smaller systems, a walkthrough might be adequate if you bring in somebody that's knowledgeable with the system. If you've only got one compressor, very often you can go to that compressor, check if that compressor is running in load unload, take a look at the ratio of loaded versus running hours. That kind of tells you how efficient that compressor is producing the air, right? If there's a large amount of unloaded hours. And then, the auditor might look at or feel, shoot temperatures, look at pressures, look at things that are wasteful, right? Might not take very long. A
Mm-hmm.
medium-sized plant, 7-day data logging would be fine. A large plant with lots of end uses and waste, a full audit and permanent monitoring might be the best bet for them.
There's some stuff that I'm going to skim through just to help stay on time here.
Sure.
This is a decision tree. It is in the participant workbook, so be aware of that. One thing that we do see a lot is that evaluating performance through an audit is just one piece of the puzzle, and oftentimes there's a big gap in facilities around knowledge of compressed air. I still go into facilities and people ask like, how expensive can it be? It's just air, and they're shocked by the actual operating costs. So I think like you've mentioned the compressed air training, and there's other resources in the book that are really useful. It can be really great to build that understanding within your organization. There are also some resources available in terms of what should be in a compressed air audit that are available, like what should be collected and measured. So there's some good references there, ASME and others that are in there. In terms of preparing for an audit, what are some things that people in the facility should be really thinking about?
Yeah, so audit costs money, so there has to be resources and funding for it. You need to have some management support. You can study things all day, but if the management are they're not going to pay for any improvements, well, it's a waste of time, right? You have to have good communication. The people in the plant know where all the skeletons are buried, right, in systems, or why things have been adjusted the way they are. Um, you need good access to information, including maintenance costs and things like that, access to people who know the plant. And really, you need clear assessment goals. Why are you studying the system in the first place? Is it because you're doing an expansion? Is it because you've got low pressure? Something like that. And then a scope of work upon which an auditor can understand what you want done.
Okay. And then I think we have some examples from your experience, Ron, of what this can look like or the results.
Yeah. So this is a gypsum board manufacturer, in my neck of the woods, but it could be any, right? They're having some problems, right? And this is the reason why they pulled in an auditor. We were providing free audits at one time in Manitoba, where I work, but their compressors are getting old, right? And they're shutting down. They had low pressure problems, causing problems with their dust collectors. That's pollution control devices, right? Low pressure during high flow events. They had water in the compressed air in the summertime, frozen airlines in the wintertime. So they weren't happy, right? So they brought in an auditor to look at their system. All right. Now, when we uh, when we looked at the system, we found problems, right? Could you go back to that last slide? Yeah. So we were able to determine their weekday, right? They weren't operating 100% of the time, only 4.5 hours per day. We could see the flow rates, the peaks, the leakage levels. We measured the power. We could see dryer purge was pretty significant and constant, right? Even running outside of those production shifts, right? And then we could calculate the KPIs. We could see specific power was 23.4 when we ignored that 180 CFM purge. And including the dryer, 34.4. Now, in a nice efficient system, the KPI should be around 18 on a large system, right? Maybe higher, 20, including an air dryer, a desiccant dryer. So, that number showed us that there is problems, right? So we calculate the operating cost. We were able to gather up some maintenance information and loss production information and get a good baseline. Next slide. Yeah. Okay, so when we took a look at the pressure profile, we can see it there. The black line is the discharge of the compressor. The blue line is after the air dryers. The green line is somewhere out in the plant. Pretty significant pressure drop. So we found an issue with the butterfly valve that had a broken handle. So the handle showed that the butterfly valve was open, but it was actually almost fully closed, right? So the pressure profile, as we move the pressure monitoring devices closer to that valve, we could understand that was a problem, right? So we did looked at the KPIs and everything. Recommended they go with a variable speed drive compressor, put the other compressor in automatic start so it wasn't running all the time, installed significant storage to stabilize the system, um, put in a better dryer with a dew point controller, right? So that it wouldn't be purging that 180 CFM all the time. It was externally heated dryer consumes half that and less with a dew point control, right? It doesn't have to be purging all the time. We bumped up the filter size and used the heat of compression to heat the plant, right? And installed a monitoring system, a permanent monitoring system on that system. Those are the recommendations, and that was actually done. Next slide. Yeah, so the improvement measures, we have a table showing the improvement measures, and we can see that compressor, the new variable speed drive compressor, is quite significant, saved, and the air dryer purge was significant, and very often that's missed, right? If an auditor is just looking at the supply side, just the compressors
Mm.
itself, and ignoring the dryer. So we also recommended, obviously, to replace that, fix that butterfly valve, fix leaks, and installed some receivers at the dust collectors to reduce the pulse frequency and give the cleaning method a lot more power to clean the filters. This project had a payback of 1.5 years, including a utility incentive of $45,000. So if the consultant only focused on changing out the compressor, a lot of those other benefits would have been missed, right? So it's important to have a full audit done, and the problem of the closed valve would be missed as well if they just put pressure loggers right in the compressor room, like so many auditors do.
All right. So when you're thinking about the audits, I think some of the big things around setting the scope, there's the facility size, goals, what do you want to achieve? That can inform the duration and what's being covered. You know, what data is available, and that you want to collect as part of that audit. And, you know, are you including scope for both the supply and demand side? I think Ron had some great examples of the value of including the demand side in it. So when preparing to scope your audit, you know, you want to start gathering some information. What is your facility size? What is your current equipment that you have and the specifications? What data do you currently have available? Why you're doing the audit? And then defining what you want to get out of it. Supply versus demand side, what needs to be measured, how long to measure that data for, and also indicating, making sure that whoever's doing the audit, that you want that raw data that they collect included as part of the report. So I think it's really important in those audit deliverables, make sure you're asking for the raw data so that you can review it, so that others can review it, that you're getting some of those key performance indicators that Ron mentioned, that you're getting recommendations for system improvements, and that there's some work going into the return on investment and estimating those savings, but making sure that they're including what their assumptions are. Like, what are the electricity rates and the assumptions that are going into those ROI payments or ROI calculations. Any tips on choosing providers, Ron?
Yeah, it's pretty tough to recommend, certain auditors and things like that. But there's certain things that you could ask the providers, right? And this is right out of the Compressed Air Challenge uh, guidance on choosing providers, right? Find out how experienced their staff is in doing assessments. Maybe check with others that have had assessments done, right? And make sure that leak detection is done, but the audit should include more. So when you call an audit just leak detection, it's more than leak. You need more than that. You need to know how those compressors are being controlled, so that you can get the best savings for your efforts, right? I always want recommendations to be product neutral so you can shop around, right? And should only recommend solutions if needed, right? If you've only got two compressors, really you don't need a very expensive compressor controller, right? Small compressors can work just fine with manual adjustments, right? And should be performance based, not brand based. That's hard to do sometimes if you've got all your compressors are the green color, right? Uh, very often people will choose green, right, for the replacement. But I would suggest go look at the KGI numbers, right, and make your choice based on that.
We have a question about in scoping the audit. How do you decide the hours cost it'll actually take for a complete audit when maybe you don't know yet what kind of problems you'll come across? Like you mentioned some of those ones in your examples, they were kind of surprises that were found along the way. So how do you scope out the amount of effort that's going to go in?
Yeah, it's hard. Usually built into an audit, right? So I wouldn't charge any extra, if I was doing an audit. I'm retired now, but yeah, it's just one of those things where you expect to hours in the plant. Now there could be some really strange things that happen that would cause more hours to be expended, but sometimes you would have to negotiate a price based on hours to fix that sort of thing. But
Hmm.
it's kind of it's a fuzzy answer, and unfortunately, but usually it's part of the audit price, coming across things like that.
Okay. We do have some tips for assessing audit quotes. These are in the participant workbook. I'm going to skim through. Is there anything like particular that jumps out here, Ron, that you want to highlight before we move on?
No, it's pretty straightforward. Yeah, it's just one of those things where the bias, right? The bias sometimes changes the recommendations, right? If you're selling equipment or not, right?
Mhm.
And when myself, I don't sell equipment, but I could say my audits are sometimes biased towards energy efficiency rather than inefficient, right? So I don't know, there's always biases, and you just have
Mhm.
to take that with a grain of salt.
We do have links to some resources like the Consortium for Energy Efficiency. It defines a minimum scope for an audit, so that can be a really useful reference if you're planning one. And things to make sure that are included in the report, the baseline profiles, those key performance indicators, and really make sure that they're documenting assumptions. They're always going to like make assumptions in calculating like the payback on opportunities or things like that and make sure that those are documented so you can see those, that you can verify if they're reasonable or not. Um,
Yeah, that's right. Yeah, I've come across projects where at the end of everything, the power consumption was more than the original um, system. And because we documented all the assumptions and conditions, we could tell, right, it was one of those projects where they expanded the plant, right, and increased their air load, right? So you can adjust based on those captured key performance indicators, and the system was much more efficient, but it consumed about the same amount of energy because they were consuming more flow because they have add an
mm,
additional production line, right? So
mhm, yeah. And I think some of those key things to question are, what operating hours are they assuming? What electricity rate are they assuming? 10 cents a kilowatt hour, 15 cents a kilowatt hour. Are they assuming leakage rates or actually measuring it? And that baseline data quality as well. Some red flags that we've seen is, recommending a larger compressor without looking at a demand reduction opportunities that might be present, savings based on inflated rates, exaggerated run hours, leak savings that don't account for the compressor control type. So Ron mentioned, a VFD controlled compressor. If you reduce leaks, you're going to get pretty good savings on that. But load unload or modulating compressors, you're not going to see the same level of savings by reducing flow from leak repairs. So if they need to be taking that into account in those estimates. And yeah, look out for those generic reports or sales pitches. And of course, lastly, always plan on some verification to prove savings. I think, Ron, that last example is a really good example of why that's so important, of having some M&V plans, so that you can say, hey, even though our energy consumption didn't change, it's still less than it would have been, but our usage went up, our production went up.
yeah, that's right. Yeah. And if you're accessing the money that's available from Save on Energy programs, things like that, well, they'll require you to do validated baseline, right? And then
Hmm.
measurement after the project so that they can see that their money is well spent, like any utility would do that.
Okay. And I think we have one more case study to go through here quickly.
Yeah, this is the tractor plant. I was talking about my all-time record leakage level. And if you just expand that so I can see the bullet points, I'm old and forgetful. Uh, but it was, a couple of 200 horse compressors in this plant, a very old plant. I think they had 1 million square feet that was reduced down to about 20% of the size, right? The actual production area, they were falling on hard times, right? So they had load unload control, they had non-cycling dryers, and they're experiencing problems. Their system was running 24/7, yet the production was only 8 hours a day because they were on low output, right, 5 days a week. But they weren't really measuring anything, right? They didn't know their energy costs, they didn't know their flows, right? So next slide. So we put in data loggers, and it wasn't very fancy, right? Just pressure and power and flow, right? Low cost portable data loggers, right? We could see pressure loss before and after the air dryer. That tells us whether things are operating nicely. We can see the pressure, the compressor power, right? How the compressor power, how much is wasted, how much is actually producing air, and we can see the flow profile using a flow meter. They really didn't want a demand side study in this case, so that we didn't do any pressure downstream. And they have massive pipes, right? So there really wasn't any pressure loss across the system. Massive pipes when this plant was putting out thousands of tractors, but now there are only a few hundreds. So we can see, some charts, right? We can see the typical sawtooth waveform, fuzzy line there on the top of the chart, the blue, that tells us how heavily loaded the compressor is. We can see on the pink line, it's kind of a moving average that I put on there. We can see when the flow is being consumed and when not, right? And we can see how on the green at the bottom, how much, in this case, amps, and we converted to kilowatts, were being consumed by those compressors. So we can see from the characteristic of the flow and pressure and power profile that production is only happening 10 hours a day, 5 days a week. We can see the average pressure, the flow, non-production flow, and that kind of piqued my interest. The difference between the average flow and the non-production flow is only 30 CFM. That's really strange, right? So when there's nothing in the plant, the lights are out, right? They're still flowing 510 CFM, right? So that you know, made alarm bells ring in my head. I knew that I had discovered pretty significant leakage in the plant here. So it was a massive leaky plant that was leaking about 80% of the air that was being produced. Right. So we did specific power 27. It should be 18. And with the air dryer, it was a non-cycling air dryer, so inefficient, right? It's consuming the same power no matter what, even if the compressors are off, if that dryer remains on. So it makes the system less efficient. We were able to calculate the costs of the compressors and air dryers, come up with a total. Next slide, please. All right, so the customer really, those compressors were wearing out, so they wanted to purchase a new compressor, right? And they wanted to purchase a better type of air dryer that turns its power down. And me as a consultant looked at that and confirmed that that was a good idea. And also, I asked them to reduce their leaks, eliminate off-hour end uses. We found that there's some air motors used to mix paint that were running 24/7. They didn't need to be running, right? And they're running their system 24/7 because the office HVAC system, the pneumatics on the HVAC system needed compressed air. But they could supply that with a smaller piston style compressor, right? And if they eliminated those two end uses, then they could turn the compressed air system off totally for 70 hours a week. And with it, no leaks during those 70 hours, right? And right size the air dryers for proper drying. You know, even in the hottest, most humid summer day after a rainstorm, that's the worst case condition for dryers, right? So uh, when we calculated the leakage repair, we assumed this system could be running at 16 kilowatts per 100 CFM, not including the dryer, and we calculated out they could save $14,000 in leakage costs, right? If we reduce the downtime, or sorry, the runtime of the system, there's an additional 40% savings because the compressors would not be running, 3,650 hours less operating hours on the compressor, reducing maintenance costs, right? And of course, the small HVAC compressor that would be running added $440 a year. Next slide. Right, so dryer savings, they resized the dryer, purchased cycling dryers that turned itself down, especially when the compressor system was off. They expected 140,000 kilowatt hours. We did a verification measurement, and we found that the savings wasn't exactly what we expected because they didn't fix as many leaks as they could. So the last measurement, they were still working on leaks, right? So the savings summary, we can see that pretty significant savings were gained by putting in a variable speed drive, cycling dryer, reducing the operating hours, reducing leakage, and getting a really nice $88,000 incentive from the power utility, right? So a very attractive savings project in this case. So as I mentioned, slightly less than expected savings were gained. We can see the time, weekends and nighttime activity on that chart to the right, where they shut off the compressed air system. So there's really no operating costs there other than that small compressor, right? So there's still ongoing leaks in that. So as I said, turning off the system reduced the leakage load by 40%. So pretty significant savings. Next slide. All right, so in that additional benefits were added to the electrical savings, right? So they got electrical savings, but they also got heat recovery because they directed the heat of the compressor into the plant to reduce the natural gas costs in the wintertime. They reduced their maintenance costs, right? And the simple payback of the project in its final form was only 10.5 months. So a really good one. Now this chart on the bottom right is a system curve, and that's a good thing that you can do with data collected, the time-based data. You can do a scatter plot like this. So the light green up at the top was the old system, how it varied, not very close to the one-to-one turn down, right? So they could have fixed their leaks and only gained a fraction of the savings from their efforts with the old system. The new system, the blue, is how the system is operating with the variable speed drive. It's pretty close to, not exactly, but pretty close to a one-to-one turn down. So we can see that if they reduce load, they can save as much as possible with this new better compressor control, right? The red boxes on there was data taken from the KGI sheet published for that compressor. So we can see we're pretty close to being bang on the curve that was published. Not exactly, but pretty close. So good use of data, both before and after the project.
Right. So now on page 10 of the participant workbook, we have this worksheet to help prepare for a compressed air audit and to plan your scope for it. So it includes thinking, what is the facility size, total horsepower of your compressors, what are the compressors and the control approach, what you want to get out of it, and some of that other information. So I would really recommend using this as a tool, but even now going through there and look through that sheet on page 10 and think about your facility of like how would you respond to these questions. If you didn't get the participant workbook earlier, Evan just dropped the link in the chat, so you can open that link and then click download to get your own copy. And we do have some more time with Ron. If anyone else has any, we've had some great questions so far. If you have any other questions, raise your hand or drop it in the chat. And I do suggest looking through this sheet and thinking about, okay, how would you answer these questions for your facility? Because that might raise some questions that you might have for Ron to clarify some things. So while you're taking a look at that, we do have a question from Mike in the chat. If you would recommend any particular pressure monitoring meters.
Yeah, well, pressure monitoring meters are kind of a dime a dozen, right? But it's important if you want to do permanent monitoring of your system to purchase a fairly high quality, accurate meter. It could output maybe 4 to 20 milliamps or some sort of digital signal, right? And then have a data collection system. Very often large plants already have some sort of system where they're measuring their process variables, right? And feed that pressure into that system, come up with a dashboard, right? So you can see what the pressure is doing over time, right? And keep monitoring that to see if you're having a pressure problem when it's happening, right? And you might want to add instrumentation like maybe kilowatt meters to your air compressors, right? Flow meter, right? Could be analog or digital, feeding into the same system, right?
Are
So
there any particular brands, like you mentioned, like having quality pressure ones, if they're going to be permanent, are there any brands in particular that you'd recommend or have used?
not really these days. You can go to any kind of process instrument supply store and just find some fairly accurate 2% pressure transducers, right? That could be used, right? These days, pressure transducers. Back in the old days, there could be low quality, but these days, just about every pressure transducer is of good quality. So yeah, just go to I don't know the regular electronic supply stores that you can find
Mhm.
on the internet and purchase whatever you need based on what equipment that that you have, for data collection.
Right.
There are some compressed air companies like, say, VP Instruments or calms.com, calms.com, or others that provide data collection systems so that you can assess the key performance indicators of your system and measure flow, right? CDImeters.com, has a flow meter that could also has a pressure monitoring device in there
Mhm.
as well as an option. Uh, Digital or analog outputs that could be fed into a data collection system. And then there's other instrumentation suppliers that provide some good data loggers that could capture time-based samples, right? Based on connection to those instruments if
Mhm.
you don't have a system for yourself.
Um, if anyone does have any other questions, please raise your hand or put them in the chat. We have a couple of last things to get through here. Oh, Josh is just bumping. Oh, here's a question. Oh, sorry, Josh. I think I missed that earlier. Compressed air drawings often show the use of a central flow controller. Any thoughts on this practice? I rarely see them being used. Can they effectively manage artificial demand without adversely impacting overall system efficiency and user performance?
Yes, they can. They are rare because various people don't believe in their effectiveness, right? Pretty much every compressor supplier can supply you with one of these, and they're basically a very precise regulator, right? Electronically controlled regulator. So you could be, operating your compressors between say 110 and 130 psi, through the control range, but the plant will not see that fluctuation, so it kind of takes away the artificial demand. You might set the flow controller to a pressure of 100 psi, and the plant would stay at that pressure, and it eliminates that artificial demand that's caused by the plant seeing that 110 to 130 psi pressure range as the compressors are loading and unloading, right? So uh, they're controversial. Not everybody believes in them. So in various areas of the country, people rarely see them. But in my neck of the woods, when I was operating, I was employed by a power utility here. We put in hundreds of these things, and they're there today, saving people lots of energy.
Great. Thanks, Ron. In terms of call to actions, I think some of the key takeaways that compressed air is too costly to ignore. And those studies really, I think Ron's examples, those studies really can reveal some hidden savings. And it is important to really understand your compressed air system, both through training and conducting these audits both play a really important role. And then also, audits don't save energy. It's the action you take using the information from the audit that saves energy. So making sure that you have, those processes, systems, accountability in place so that the recommendations that come out of it do actually get acted on. We do have some resources in the participant workbook at the end, links to those that can be really useful. The Compressed Air Challenge Library is a great resource. And there is also some upcoming training on November 13th, Fundamentals of Compressed Air Systems, organized by CIAT. You can register for this. Evan dropped the link in the chat. There's a cost associated with it, but 50% of that can be covered through Save on Energy rebate on there. We do have a question regarding amp measurements and how do you manage that during an audit? Do you hire an electrician to install those, or is there someone who has the ticket to play in the electric box on site?
Yeah, I work in Manitoba, so I have a special electrical license, so I can do it. But the key thing is safety, right? So it's always best, especially in places with large arc flash capability, right? That could kill people, to do the measurements safely, right? So that's one of the things about kilowatt readings is you have to measure voltage and current. But if you just measure amps, right, you're connecting your amp logger to insulated conductors that represent way less risk. But always do it with qualified personnel like an electrician.
Mm-hmm. Great advice. I do recommend Save on Energy has some great tools, resources to help stay connected. There's a link here. I'm just going to copy that. I'll drop that in the chat and make sure that it goes out. If there's any support that you want following this workshop, anything we talked about, please reach out and we can arrange some support through that. And also monthly bulletin, live training calendar, support page. And one last thing I'll note is we just finished the first season of the Energy Managers Playbook, a podcast by Save on Energy that talks to energy managers and hears their stories about challenges they faced, how they overcame them. A great resource to hear about some of the excellent work happening with energy managers in Ontario. A quick heads up that you may receive a survey via your email. It will be sent from surveyinfo@forumresearch.com, so it's not a phishing scam. We really do appreciate your feedback on these workshops and how we can continue to improve them and serve the energy manager community. And that brings us to the end of the workshop. Thank you all for taking the time to attend it. I have one request before you leave. If you could just share in the chat what's one thing you will do in the next week to plan or improve upon your next compressed air audit. So thanks everyone for coming. Thanks again, Ron, for joining us today. Really appreciate you sharing your wealth of expertise.
Glad to be here.
I plan to tell my colleague to start doing an audit. That's a great next step. And I think it also follows that great adage of whoever doesn't attend the meeting gets delegated the tasks. Great to see. All right. So thanks everyone. We'll be shutting it down and hopefully we'll see you again next time.